All right, nothing to see here. They just want slope, punch it in, I get a half. I didn't even bother reducing it. Number 2, you have data here. It's gallons of water. It's actually cooked data from a function where we know the data. I actually plotted these data inside Excel so you can see a picture of what's going on. So what is wanted here is, if you notice, it's not a line. And so as water starts to drain from this tank, you actually have a big drop at the very beginning and less so at the end. And so the slope is not uniform across this entire group. So you're trying to estimate what the slope would be right at that value P, at that point P. And what's asked of you is to find the slope between Q and P, where Q varies between these other data points. And so for the first data point, let's see, we have Q is chosen to be the 0.5688, and P is my point of interest. And I just calculate the slope between those 2 points. So the Y value I highlighted in here. Here's my P, and my Q is 5 and 688. So I take my Y2, which was 245, and subtract my Y1, which is 688, and take my X2, which is 15, and subtract my 5, which is my delta X. And so I get minus 44.3. That's where that comes from. And then they want you to do it with the same thing with the other choices of Q. And here's my second Q. I still keep the same P, but now what's changed is my Y2 and X2 have changed. My Y2 is 437. It's this point right here. And my X2 is 10. And so that's where the minus 38.4 comes from. And then they want you to continue on. So they want you to choose the 20 and 113 and 25 and 26 and so forth to estimate these. And one way that you can, now that I have all these, I can ask, well, what is like approximately the slope? Well, I can just take the 2 nearest neighboring data points that I have and just average them. So if I take the average of these 2 guys that are right around the 15, divide those by 2, I get minus 32.4, which is what is wanted here. So it's not very complicated. It's a very natural way of how to do things. And this is how we actually do things these days, because most of what we have is data. We don't have functions. The reason why we used calculus in the past is we didn't have data and we didn't have computers that could handle those kind of data. So this form of doing things is the way we do things.